All right, we want to begin now in section 3.4 video. This is part 1. And for those of you that had the intermediate algebra course, a lot of what we're going to say over the next 2 sections you saw in the intermediate algebra course. So that's what we're going to talk about here is linear equations. Before I do that, let me back up just a second and talk about one thing that we've already covered. One of the things that we covered in section 2.2 was we started talking about equations with 2 variables. And I told you that an equation with 2 variables, the answer to an equation with 2 variables is a pair of numbers because it has an x and a y in it. So you have an x answer and you have a y answer. So every equation that has 2 letters in it, typically the solution is written as an ordered pair. But I also told you not only is the answer a pair of numbers, there's millions of them. So because of that, we can't write out all of the answers to those problems. So we don't try to write out the answer to all of those problems. What we do instead of writing out all the answers to those problems is we graph those equations. As a matter of fact, you may not remember it, but in section 2.2, I told you that you would never see an equation in mathematics that had 2 letters or more in it where it said solve above it. Typically what it will say is graph. Now, remember I also told you this, when you graph an equation with 2 letters in it, and you draw your graph, whatever it happens to be, that graph represents all of the solutions to that problem. For instance, what type of graph did you have on your midterm exam? You had the graph of a circle. And so what we did was we found the center and radius and we drew the circle. But if you'll remember, I told you, I said, whenever you graph in mathematics, you have to know what the picture looks like. Otherwise, you don't know how to connect your dots. Remember, I told you if you have a point here and a point here, and I said draw a graph that goes through these 2 points, you don't know if it goes straight or goes up and comes down. So you have to know what the picture looks like first. So I told you whenever we started graphing a circle, I said the first thing you have to make sure you know how to do is this going to give me a certain picture? Secondly, if it's going to give me a certain picture, what does the picture look like? And then thirdly, how do we graph it? So when we graph circles, I did not jump into the graph of a circle and show you how to graph a circle. What I did first was I showed you how to identify the equation of a circle. And I told you this, every circle, the equation, your x and your y were both squared, and the number that was in front of the x and y squared had to be the same number. So if you had a 7x squared, you had to have a 7y squared. But both letters had to be to the second power, and the numbers in front of them had to be the same. You may not remember me telling you that, but I did. So that was the distinguishing feature about a circle. So when you saw that, you knew the graph was a circle. Then, once you realized it was a circle, we set out to find the center and radius. Why did we do that? Because to graph any circle, you have to know those 2 features. If you will remember, there was some of the circles that I gave you that were in center radius form. They were in the form you wanted it in. But then there was some that was not, where we had to complete the square to put it in center radius form. Okay, now what we want to talk about in this section is we want to talk about linear equations. Now, this is not the first time you've heard me talk about a linear equation. The first 5 problems on your test, on your midterm test, came out of section 1.1. Those were called linear equations. And I gave you a definition at the beginning of the course that said this: a linear equation is an equation that can be written in the form ax equal b. Now, you had another kind of equation on test 1, which was called a quadratic equation. That was you had 4 or 5 problems on that. That's where we factor or use the quadratic formula, etc. Now, what is the distinguishing feature between a linear equation and a quadratic equation? I told you what the difference is. You may not remember it, but I told you this. A quadratic equation, your variable, your x, always had to be squared. In a linear equation, your x always had to be to the first power. If you can remember back the 5 problems, 5 or 6 problems on your midterm test, those were all linear equations. One variable, and x was to the first power. All of those problems came out of section 1.1. It's where we get the x's on one side, numbers on the other. But the main thing you need to hear is all of those equations, your x was to the first power. Now, we're talking about graphing, and we're talking about 2 variables. So, what we're about to do now is I'm about to give you a definition for a linear equation with 2 variables. So, let's start out and take down this note. A linear equation in 2 variables is in standard form if it appears as the following. So a linear equation with 2 variables. Standard form. Now, standard form is not that big of a deal with lines, but anyway. So write this down right here. AX plus BY equals C. So, what's the difference in this linear equation and this linear equation? This linear equation up here has 1 letter in it. This linear equation down here has 2 letters in it. But they're still both linear equations. Now, what makes this linear? Remember, with a circle, the x and y had to both be raised to what power? Second power. In this one, the x and y are both raised to the first power. Now, does both letters have to be present for it to be called a linear equation? No, because this is called a linear equation. So you don't have to have both letters in a linear equation. You can just have one of them. So that's why there's a stipulation here, and it's this. A and B cannot both be 0. So then what does this mean? If A and B cannot both be 0, that means then that one of them can be. So that's saying what I just told you. It means that if the A is 0, that means you have just a y in the problem, no x. If the B is 0, you have just an x and no y. Now, there's no stipulation on this number over here. It can be anything. It can be 0, positive, negative, fraction, etc. There's no stipulation on these, other than they both can't be 0 at the same time. So here's what this is saying. Every linear equation, you will have either just a x, or just a y, or both. But either in any of those 3 instances, all the variables are always to the first power. So if I have this, 7x plus 3y equal 10. That is a linear equation, 2 variables. 5x minus 4y equals 0. Linear equation in 2 variables. 8x equals to 10 minus 3y. Linear equation, 2 variables. Now, these 2 are in standard form because your x's and y's are on one side and your numbers on the other. That's all standard form for a linear equation means. It just simply means this. Your x is first, your y is next, your equal sign is next, and then the numbers over on the other side. That's standard form. So is this a linear equation? Yes, but it's not in standard form. Now, I could put it in standard form. All I have to do is move the 3y, add 3y to both sides to get the 3y over here. So if I wanted to take this problem and put it in standard form, I would just rewrite it this way. Now it's in standard form. But it's a linear equation whether it's in standard form or not. Okay, now, if I have this, if I have these two, once again, this, zoom that out just a little bit. Okay, this is a linear equation. So is this one. But the difference in these two, these are linear equations in one variable. These are all linear equations in two variables. What makes them linear? Because every variable is to the first power, whether you have the x or the y or both. All right, so that's all I want you to see right now is what a linear equation looks like. Okay, now, the next note. Write this down. The graph of all linear equations, the graphs of all linear equations are straight lines. The graphs of all linear equations are straight lines. So, let me say one more time, as if I haven't said it enough already. Of all of these you're looking at, how many of these are linear equations? Every one of them. What makes all of these linear equations? You have an x or a y or both, and they're to the first power. So if I graph this one, this one, this one, this one, and this one, what would the graphs look like? Straight lines. And the reason is if you look, here, listen to the word linear equations. What does the first four letters in the word linear spell? Spells line, L-I-N-E-A-R. So L-I-N-E is the first four letters in the word linear. So when we graph these in a little bit, and we will soon, we will see that all of these are straight lines. Okay, now, take down the next note. Here's the note. When graphing lines, there are three types. Number one is a slanted line. So that means it either is slanted uphill or slanted downhill. Number two, a vertical line. That means that the line is straight up and down. And then number three is a horizontal line. That means the line is perfectly flat. Now all of these are lines. All of these are straight lines. So when we categorize lines, they're either look like this, they look like this, or they're slanted uphill or downhill, depending. Okay, let me give you another note. This is a very, very important note that I'm about to give you right here. Here's the note. To determine if the graph of a linear equation is slanted, comma, vertical, comma, or horizontal, use the following outline. Okay, so here's what I'm about to do. I'm about to show you, when you look at that problem, you already know how to tell if it's a line or not. If it has an X or a Y or both, and they're to the first power. So all those problems we wrote up a while ago, all of those were lines. But here's what I'm about to do. I'm about to carry it a step farther. I'm about to actually show you, when you look at that problem, how you can tell if that line will be slanted, if it'll be vertical, or if it'll be horizontal. And here's how you do that. This is very, very important right here that you memorize. Okay, here's what this means. If the equation has an X and a Y in it, the line is always slanted. Always. But now they got to both be to the first power. If it has just an X in it and no Y at all, it looks like this. And if it has just a Y in it and no X in it, if it's to the first power, it looks like this. Now, I will explain why a little bit later on. But it would be well worth your time in order for you to memorize this. But now remember, the X and Y have to be to the first power. That's the whole preface to this statement right here. So here's what I'm about to do. I'm about to flip back to the previous page and look at those that I wrote up. And let's see if we can tell. So let's go back. And if you wrote these down, you can write it out beside here. Now, we're not ready to graph yet. But is this a linear equation? Yes, because X and Y are both to the first power. This linear equation is a slanted line because it has both letters. This one is slanted because it has both letters. This one is slanted because it has both letters. Now, this is the same as that one. Now, look at this one. This one has just an X in it. So when we graph this one, and we hadn't talked about how to graph it yet, but when we graph this one, it's going to look like this. When we graph this one, it's going to look like this. Now, let me give you a caution about something. Every semester, I have students that gets this one right here and this one right here, these two, backwards. Let me explain why. If it has just an X in it, what kind of line is it? It's vertical. If it had, that means up and down. If it has just a Y in it, it's a horizontal line. That means it's straight across. Now here's why I'm giving you this caution. Why do students get this backwards? Here is why. Which way does your x-axis run? Your x-axis runs this way. But when you're graphing with just an X in it, it's a vertical line. So it's really just the opposite of this up here. Same thing here. Which way does your y-axis run? Up and down. But when you're graphing an equation that has just a y in it, it's horizontal. Now again, I'm going to show you why later. You just need to know this right here. Know those three facts. Now, we're going to revisit that. We're going to come back and revisit that in a little bit. Okay, before I do that, I want to lay that down. And what I want to do now is I want to talk about the slope of a line. And I will do this discussion in the next video.